Fantastic. Thank you for that introduction, Sam. Really appreciate it. And it's an honor to be talking here in front of you guys today. So I've got a pretty light talk for you guys about DNS-based OSINT techniques for product and service discovery. Now, just a quick raise of hands. How many of you know what DNS is? Okay, great. If no one raised a hand, I'd be pretty concerned. How many of you use DNS TXT records for product and service discovery? Okay, awesome. Not too many, so hopefully you can learn quite a bit today. So a bit about myself. I'm a security researcher based in London. I work for a cyber risk management company called Kind. So we've got offices in London, also Porto and the States. And a lot of my role involves researching into vulnerabilities and looking at different products and services over the internet and fingerprinting, different firewalls such as Fortinet, SonicWall, etc. And yeah, today, obviously, I'll be talking about DNS OSINT techniques on, how we could detect various different products and services which typically aren't discovered via HTTP headers or within the HTML body when you access a page. So a bit about DNS for those who didn't raise your hand. DNS basically acts as the address book of the internet. And it essentially maps domain names to IP addresses. As you can see, we've got quite a few DNS types. We've got A records, PTR records, MX records, which is used for mail services, CNAME, and of course, TXT records. Now, TXT records is what we'll be looking into today. And it's essentially a DNS record type for storing text data. Now you have like various different types such as SPF, DKIM, and DMARC, which are typically used for email security. And in addition to that, we have app security or third-party services, which is what this talk will be about today. And finally, we can have anything else. By anything else, I literally mean anything else. Like you could add a TXT record, which says, OWASP is awesome. And yeah, so this slide here essentially goes into a test scan I'm running against adobe.com. Now this tool I'm running is DNSX, a tool by Project Discovery. It's open source. And you'll be able to see to the left, we have the domain name, which is of course adobe.com. We have the record type, which is TXT. Now the text in green is essentially the product and service, which is the most important thing we'll want to focus on today. So you'll notice, there's OpenAI, GlobalSign, Atlassian, Google Site Verification, Cisco, and Drift. Now that could obviously tell us they're running those particular services on their infrastructure without obviously even touching their infrastructure. Now, we have a verification string, and all this really is a string which tells that third party that, that domain belongs to, them essentially. Now, that doesn't really mean anything to us. It essentially allows, that third party to, verify that domain, essentially. But yeah, the text in green is the most important thing here. So you can see they're running a number of services, and you might wonder why this could be useful. Is mostly because these services you typically can't detect via HTTP headers or HTTP response bodies. For example, from the top of my mind, I would think that you can't detect GlobalSign infrastructure from externally facing assets. And I see that as, quite a big win, being able to detect GlobalSign. Because think of, red teaming, for example, or think of, you're a bad actor and you want to find infrastructure a company uses. You could essentially put together a phishing email, which looks like a GlobalSign form. And you could send that to the CEO and they'll likely fall for it because you have that, additional knowledge that they're running GlobalSign infrastructure. And, typically CEOs, they sign a document and they move on to the next one. So it's, it comes second nature to them, and they don't like necessarily think about it when they, sign documents. So yeah, that could be, quite a useful, way to utilize this. Um, but yeah, outside of that, there could be dangling TXT records. So what if a company has a service, they no longer use it, but their TXT records might still be there. Now that's something, you'll need to be mindful of. So don't always take this as, definitive, but they're running these, services. Now, quick raise of hands. Who works in incident response and deals with supply chain attacks? Okay, not many. You might be aware of the sales loft trip supply chain attack, which took place in August and September of last year. And essentially, bad actors stole OAuth tokens from the sales loft trip app, and they'll use to access sales loft data and steal, gigabytes of company data. Now, major companies were affected by this, such as Workday, Adobe, Cloudflare, NetApp, etc. Um, and with this technique, we could easily utilize DNS TXT scanning. So as you can see, I've run a quick scan on a couple of domains, and we could see Adobe, Workday, Cloudflare, and NetApp are running DNS sales of drip products and services on their infrastructure by simply querying DNS servers. Another useful thing about this technique is you don't necessarily have to touch target infrastructure in order to detect these products and services. So these companies will never know that that they're running this infrastructure because you're querying DNS servers as opposed to target infrastructure on these companies itself. But yeah, this is again using a tool called DNSX. Later on, I'll be doing a demo on two open source tools, OWASP Amass and Nuclei. So look forward to the demo. And yeah, you might be wondering why this might be useful. Many ideas come to mind, but the top three can be prioritize threat hunting. You can also assess third parties risk by understanding shared supply chain exposure. And finally, you can also accelerate incident response through proactive detection. And of course, this goes without saying, you could also run this through Amass and Nuclei. So a lot of my work last year built this integration into two open source tools, Amass and Nuclei, which I will go through now. So I've got a quick demo for you guys. Fingers crossed it works. Okay, so if we look at Amass first, so Amass is a framework, and essentially you'd have to run the enumeration command before you can query the data. Now, the enumeration command is quite simple. I won't run it now because it might take a while, but I ran it before this presentation. But it goes like Amass, enum, -d, and then your target. Sure. Can you see that? So this would be your enumeration command, and that will go through your scanning of any given target. Once that is completed, the way in which Amass stores the data is in a database, which is automatically set up locally. And the way in which we can query that database is using triples querying language. And I've got a command here, which is the assoc command, which queries the database locally. And you can see that you can see that they've got these services by these companies that are associated with
Mic. She need it. Let me. Yeah, can I actually stick it on you?
Sure. So yeah, they've got these companies which are associated with OWASP, which obviously you can tell they're running Atlassian services, Microsoft services, etc. Now this is quite simple to run as well. And if we switch over to Nuclei, I run a quick scan on google.com, and you can see that we've got a couple of matches as well. So we can see Google have Apple services, Facebook, they're utilizing Google Workspace, which of course makes sense. DocuSign, Cisco Cloud Intelligence Platform, which is quite useful actually, because you typically can't detect that, via the traditional HTTP body response scanning, and of course OneTrust. And yeah, this is typically how I run these scans. The commands are quite simple, and so this one in particular uses a Nuclei template, which is of course accessible via GitHub. If you were to contribute to the Nuclei open source repo. So I do have the files open over here. I don't know if you can see that. Let me zoom in. So this is the Nuclei template. You've got obviously basic information about the template itself. And of course, you've got each verification matcher. So for Keybase, you've got, you're matching on this keyword within the TXT record. And of course, you've got, a whole load of verification strings, which it would automatically go through when running the command one by one. So yeah, you could, see Dell, 1Password, etc. And the amass integration is done via plugins, and it's written in Go, and the mappings are over here. So it's obviously quite similar in that you've got the verification string and the associated company, such as BugCrowd verification, and it's related to BugCrowd Incorporated. Now, the best part about these tools is they are both open source, as I previously mentioned. So any one of you can contribute and build on this list. Now, obviously, we would need to verify these strings are actually in place when you open these PRs and submit them to GitHub. But yeah, everything's open source. You can see exactly what's going on, how the code works, how it's all running. And yeah, that's the demonstration complete. Fortunately, it worked to plan, but yeah, that's kind of everything from me today. Does anyone have any questions?